All right, if you're gearing up for a .NET interview, you know the fundamentals are absolutely everything. So in the next few minutes, we're going to blast through the core concepts you need to know, from the engine that actually runs your code to the patterns that make it awesome.
And look, it doesn't matter if you're aiming for a junior role or you're a seasoned pro, these are the non-negotiables. Think of this as your rapid-fire guide to make sure you're ready for the questions they're definitely going to throw at you. So, we're going to kick things off right at the heart of .NET. Because let's be real, before you can build amazing software, you have to understand the machine you're working with, right? This is probably the first question you're going to get, and it really sets the stage for everything else that follows. So, what is this framework that we're always talking about? The best way to think about it is as a complete toolkit for developers. It's so much more than just a language. It's an entire ecosystem. You get the Common Language Runtime, the CLR. That's the execution engine. You get this massive base class library, or BCL, which is just tons of pre-written code for pretty much anything you can imagine, from file access to networking. And of course, you get all the tools to glue it all together. So if the .NET framework is the whole car, then the CLR, the Common Language Runtime, is the engine. It's the powerhouse that actually takes your code, makes it run, and manages its entire lifecycle from start to finish. The CLR is kind of like this super diligent manager working behind the scenes. Its to-do list is huge. It handles automatic memory management through something called garbage collection. We'll get to that in a sec. It provides structured exception handling, so your app doesn't just crash and burn at the first sign of trouble. It enforces security rules, and, maybe most importantly, it performs just-in-time or JET compilation. That's a fancy way of saying it turns your code into native machine code right at the moment it's needed. Okay, so we've seen the engine. Now let's look at the actual building blocks. In this next part, we're going to dig into how .NET code is actually structured, packaged up, and then managed in memory. After you've spent hours writing all that beautiful C# code, and you finally hit that build button, what do you actually get? What's the physical thing that comes out the other side? What you get is an assembly. This is the fundamental package, the unit of deployment in .NET. It might be an executable file and .exe that a user can actually run, or it could be a dynamic link library, a .dll, that other programs can use. It's basically a self-contained box with your compiled code, all its metadata, and a manifest that's like a table of contents for what's inside. Now this is so critical for understanding performance, knowing where your data lives. .NET splits memory into two main places. You've got the stack, which is like a neat, tidy pile of plates. It's super fast, last in, first out. This is where simple value types like integers, booleans, and floats are stored. Then you've got the heap. Think of the heap as a big, sprawling warehouse for your larger, more complex reference types, like objects and arrays. When you use a reference type, the stack just holds a tiny little address that points to its actual location in that big warehouse. So what if you need to treat a simple plate from the stack like a big box in the warehouse? Say you want to add an integer to a collection that only accepts objects. Well, that's called boxing. You're literally wrapping that value type in an object and moving it over to the heap. And as you might guess, unboxing is just the reverse process. It's something you have to do sometimes, but always be aware it comes with a performance cost. Okay, so we're creating all these objects on the heap. We're filling up that big warehouse. But what happens when we're done with them? Who cleans up the mess so we don't run out of space? Well, this is where our diligent manager, the CLR, comes back into the picture. This is where the genius of .NET's garbage collector really shines. It's all built on one simple observation. Most new objects are very short-lived, so the GC runs most frequently on generation 0, quickly cleaning up all the new stuff. Now, if an object survives that first cleanup, it gets promoted to generation 1. If it survives another cleanup, it gets promoted to generation 2, which is for really long-lived objects. By checking the old stuff less often, the GC avoids wasting time, which makes the whole process incredibly efficient. All right, we've covered the engine and the building blocks. Now let's talk about the blueprints, the patterns and the tools we use to write code that's not just functional, but clean, flexible, and easy to maintain. The classic interview question. An interface is a pure contract. It says what a class can do, but gives you zero implementation. For example, an iLogger interface might just say, you must have a log message method. An abstract class, on the other hand, is like a partially built blueprint. It can provide some default behavior, like a format timestamp method, while leaving other abstract methods for its children to fill in. But here's the key takeaway. A class can implement many interfaces, but it can only inherit from one abstract class. Delegates can seem a little tricky at first, but the idea is actually simple. Imagine a variable that, instead of holding a number or a string, holds a reference to a method. It points to a function. This is the absolute foundation of event-driven programming. When a user clicks a button, a delegate is what's used to call the specific method you assigned to handle that on-click event. Let's talk about control. Instead of a class creating its own dependencies, like a car trying to build its own engine, it just asks for one to be provided. This is a game changer because it means you can easily swap out those dependencies. Need a different kind of logger for testing? Just inject a mock one. This is what makes your code super flexible, modular, and a whole lot easier to test. All right, in our final section, let's zoom out and see how all of these concepts come together to build the modern, high-performance apps that pretty much power the world today. This is probably the most important distinction in the .NET world right now. The original .NET framework is the legacy, Windows-only version. .NET Core, which has now evolved into just .NET, is the future. It's open source, it runs everywhere, Windows, Mac, Linux, and it was built from the ground up to be lightweight and blazing fast, which is perfect for microservices and cloud-native applications. When a request comes into a modern .NET app, it doesn't just hit your code directly. Instead, it goes through a pipeline of middleware components. It's kind of like an assembly line. The first component might check if you're logged in, the next one might figure out which part of your code needs to handle the request, another one might log the details. Each piece has one specific job, which makes the whole system really clean and easy to configure. So how do all these modern services talk to one another? Well, most of the time, they use a REST API. It's really just an architectural style, a set of rules for building web services that are simple and scalable. By using standard HTTP verbs like get to retrieve data and post to create it, and communicating in a universal format like JSON, you can create an API that any client, from a web browser to a mobile app, can easily understand. We've covered a ton of ground, from the CLR all the way to the cloud. But as we start to wrap this up, the most important takeaway is this. This knowledge isn't about memorizing answers to pass a test. Understanding the CLR, how memory works, these design patterns, this is what separates someone who just writes code from a true software engineer. These are the tools you'll use every single day to build applications that are fast, reliable, and actually maintainable. So as you prepare for that interview, don't just memorize the definitions. Really think about how all these concepts fit together. Because once you've truly mastered them, the only limit is your imagination. Now go build something amazing.